Sea level rise will raise the level of the canal and create greater impacts on surrounding neighborhoods during flood events. Existing communities with strong infrastructural assets will possess cost-benefit ratio high enough to justify protecting with more traditional gray infrastructures. Yet this provides an opportunity to rethink their function. Carroll Gardens will be protected by a multifunctionary, community access-focused dike. Area below the dike transitions to integrated seawater agriculture, which allows for periodic flooding without negative consequences. Other areas are better suited for a transition to a new community type by this time. Development is set back and up from the canal on raised earthen plinths, above the new 500-year flood level. Development atop the plinths mimics traditional brownstone style, but with greater emphasis on public spaces. Bands of green space span the plinths, creating corridors and nodes for community activities. Canal ends of the plinths are activated by small commercial nodes, complementing the ramps, terraces, industrial follies, and pools that make up the system of vertical movement down towards and into the canal. Construction of the plinths allows for the creation of separated sewer system for these new traditional communities, as well as a system of cisterns that will capture what will likely be less frequent but more intense rain events by this time. Some areas of the canal will see new techniques to deal with waste and the creation of energy. Existing industrial structures will be utilized to filter out effluent water from the adjacent sewer system. Crushed oyster shells will be heated and then mixed and stirred with the effluent, removing 68 to 98% of the phosphates from the water. Filtered water will then pass through a series of wetlands for further filtration before entering back into newly created oyster beds along the canal edge. Another system will use effluent to produce energy. New side channels will facilitate the Omega system currently in development by NASA. Effluent is pumped into permeable membranes filled with algae. Once here, the natural motion of the water, along with sunlight and carbon dioxide from the atmosphere, promote fast growth of the algae, a promising biofuel crop, and an efficient consumer of nutrients. Additionally, areas between these energy canals can be used for the production of other energy crops such as salicornia, as well as for recreation and naturalized area. In the southern transect, many industrial structures will be phased out over time due to more frequent flooding. Midground communities will be adapted to new development types that can better withstand periodic flooding. Ground levels will have new functions such as indoor public plaza or parking. Residential areas will be contained in the levels of structures above the 500-year floodplain. Along the canal, new industries still find ways to function. Floating pad structures allow for production, storage, and display of goods while keeping them out of the reach of advancing waters. Localized, craft-based industries that can function under the new conditions thrive on upper floors of the industrial areas, while ground floors stay flexible and have variable uses ranging from temporary market to parking.